Thanks, everyone. Ryan Sullivan, Director of AIS, and recently joined with the National Imaging Facility. So let me talk into two parts. One is kind of what we've done to date, and the next is where we're going. So, what is AIS? It's a national software platform across Australia, where our twofold mission is, one, to increase research reproducibility, and two, drive the adoption of innovative but trusted analysis techniques. Most researchers don't have a pocket postdoc who can take a script from a Nature Methods paper, run it up reproducibly, figure out the version was wrong, it didn't compile right, spend 3 months trying to fix it, and then repeat that for every single research group. So what we do is try to standardize, centralize, and build up common tooling so that when any informatics fellow in Australia builds a pipeline, it then becomes accessible to all researchers across the country. So you're really acting as a force multiplier for those experts. And we bring this all together into a single platform that integrates directly with clinical systems, preclinical systems, university, private radiology, public health, into a cohesive whole. So AIS works as both an open source product and a federation of partners who are running that product. So we do everything as a single GitHub organization, and we have a number of institutions who run AIS nodes, which is the institutional data repository along with all the compute, as well as a number of edge devices, which are basically data gateways that connect imaging instruments either in the university or in hospitals directly to those data repositories in a standard and secure way. So over the past 4 years, we've grown to about 570 users and about 150 discrete subjects and imaging sessions. And really the goal is, can we build that 80% common infrastructure that different groups use? So two key examples I like to give. One is the Australian Cancer Research Foundation Center of Excellence in Melanoma, and the second is the multiple sclerosis space. Normally, a neurologist and a dermatologist would not be talking to each other, but in terms of the data management, de-identification, some of the AI tools, about 80% of the digital technology is the same, and that 20% that's specific to a modality or to a different disease can then be customized and built on top. And particularly as we build as a federation, we have these federated repositories. So for ACRF ACEMED, we have 17 clinical sites across Australia, and we integrate those hospitals with the local institutions, so University of Queensland, University of Sydney, Monash University in this case, and that builds a logical repository on top of that. And for MS Space, we've done one in Australia, one in Germany for EU patients, and one in the US, so that we can have multinational clinical data collections, keeping the patient data in their home country, and be able to bring the analysis to the patient data instead of trying to aggregate it. So how AIS works? AIS is built with a data-centric computing strategy. So instead of saying you have your HPC over here, your data repository is here, it's a problem left to the user to get it back and forth and try to get the provenance of how you analyze the data. We bring all of our compute capability directly to the repository. So an AIS node is built on something called a Kubernetes cluster, which is basically a way of orchestrating containerized software, which is the dark gray background. And we bring together 4 key capability areas that operate as a unified whole. So the first, data management, we use XNet, which Tim has just gone over. And so we've worked with the XNet team and had a direct partnership with Tim's team since about 2018 to customize, expand, and support AIS. The second is non-interactive pipelines. So from the XNet interface, researchers can launch batch HPC type jobs, so file conversion, standard analysis. If you want bitwise reproducible analysis run 10,000 times, from a UI, you can just select the favorites of the software library, launch, and it will mount your data in a read-only volume, spin that up in the queue, do the processing, put the results back. So for particularly clinical researchers or people trying to answer health questions, they don't need to know what a command line is, because most don't. They don't need to know what the GPU or compiling is. They just want to know, how can I analyze my image so I can answer my research question with a tool that is vetted from both a cybersecurity view as well as a scientific point of view. The third is interactive analysis, so being able to spin up Jupyter notebooks, being able to spin up NeuroDesk and Scigit, as Ashwin went over yesterday. Again, directly from the repository, gives you a full read-only mount. So when we have data that's moving from 3 gigabytes a scan to 3 terabytes a scan, you're not having to move it between systems. You're spinning up that desktop right on the data. And it also allows us to start analyzing sensitive data because you're not bringing it outside of the system. The fourth, and definitely still very much in development, is specific machine learning services. So the two main frameworks that we're using is MONAI for image segmentation using pre-trained PyTorch models. And the second is NVFLARE for federated learning, to be able to keep data in place, whether it's in the hospital, between universities, or in the home country, and move the models back and forth into a converged model. So quickly going over the pipelines engine, the idea is we have a common deployment framework that then different imaging scientists, whether working in CT, MR, molecular imaging, tissue pathology, and microscopy, be able to contribute into a GitHub workflow. We'll build the container, undergo cybersecurity scanning, and synchronize it. So every institution who is running a vanilla XNAT or AIS can be a consumer, and then we distribute the software that way, similar to how Galaxy distributes theirs internationally. And then this is built using the Pydro workflow engine. So this is a progression of the NiPipe engine. And what this does is basically give you a extensible set of Python functions and commands that you can use to bring together complex workflows, nested with mapping, branching logic, and then builds that into a single Docker container that can then be shared. And then on top of that, there's basically a shim that integrates with different repositories. So the Arcana framework can work with any repository, but in our case, we have a specific interface for XNAT, where it will go grab the data from XNAT, map it with specific schema that the pipelines are expecting, run the pipeline, and then do that reverse mapping to map the outputs back into XNAT and put it in your project in a standard way. Mentioned interactive analysis with Jupyter Hub and NeuroDesk. So for those technically inclined, basically we have a CVFM cache which synchronizes the singularity containers of all the software on NeuroDesk or other flavors of Scigit within the institutional cluster. And then researchers can spin up Jupyter notebooks, virtual desktops that are locked off to the internet, but then have access to that cache of synchronized software so that we can share the software but still have a secure and an audited environment. And importantly, what this does is really allow us as well to add additional visualization tools. So XNAT has the OHIF viewer built in, which works quite well for DICOM or a subset of DICOM. But we've been working to add different viewers, so 3D Slicer, QPath for digital pathology, microscopy, CVAT for external cameras, video data, surgical monitoring. You could add Fiji, so Profiler, any viewer that runs on Linux, you can add there, and then that allows us to move beyond DICOM or other formats and really add to that extensibility. And just diving a bit deeper into one key use case. So as I mentioned, ACRF AceMed is national clinical trial looking to establish melanoma screening program across Australia. Melanoma is unfortunately our cancer, including myself. I'm a patient in this trial. So one of the projects we have is really needing to bring together lots of different imaging data. So you can see in this image, there are even new modalities that are completely optical based. So think of a X-ray based CT, but you're doing it with 92 4K optical cameras to build a full 3D avatar and mapping of the dermis. And you want to bring together this optical imaging, you want PET data, you want tissue explants, the microscopy of that data, genomics, patient reports, and you need to bring this all together to answer the medical question. So what we've done is extended XNAT to be able to store these different modalities in a central participant view, working to add federated learning so that we can onboard additional clinical sites and participants. As you can imagine, patients are nude or semi-nude, and some people just don't ever want to share that data with a postdoc, no matter what security. So being able to say your data can stay in the room with your physician, but still contribute to research is quite powerful. Yeah, so in short, basically from the AIS node, you can coordinate the deployment of the federated learning capability across the in-mini clinical sites, and we're looking to expand this with a new project beyond melanoma. So that's kind of what we've worked on the past 5 years under an original ARDC grant for about 1.5 million. Now we're moving into phase 2, where we have significant investment and partnership with the National Imaging Facility, which Wojtek introduced yesterday. So NIF has a data collections program. And as we know, with particularly people in this room would know, with data, you have so many things you have to get right before you can actually do the cool and fun stuff at the top. So you need your infrastructure, fair and care, harmonization, standards, and everything underneath that the researchers don't really see. So the core of the NIF investment is really to build out that seamless infrastructure that will form the foundation of NIF's digital program going forward. So what that really entails is the Australian Imaging Service team formally joining the National Imaging Facility and really providing funding to drastically expand AIS both in terms of user numbers and capability. So moving from 13 to 18 institutions, really focusing on expanding to connect that full fleet, of 100 NIF instruments. That will take time, but that's the ambition. And really uplifting how we're doing data capture. Right now we have about 7 different tools all hitting the same XNAT API. Being able to unify on a single tool that can be extensible for DICOM, proprietary, university, and hospital. So it can be used in both a research setting, but is sufficiently secure that we can use with the clinical partners. A national portal and expansion to metadata. And lastly, really building out the software catalog of what we're doing for the pipelines, for the virtual desktops, for the PyTorch-based models. Hopefully not just in Australia, but internationally with the wider community that is using XNAT or using Pydra or using Scigit. And lastly, building up that national community of practice. So the team as a whole is growing quite large. So the NIF project just kicked off April 1st this year. So we're still have about 7 roles still in recruitment. So we're expanding the team and scaling up. But it is a very exciting time for the next 3 years as we can really put the foot in the accelerator here. And two last things I'd like to touch on is cybersecurity and privacy are particular issues in the industry and of growing importance. As the imaging data increases in resolution, becomes more inherently identifiable, and we bring data together. 2 of the things we're really looking is establishing shared context So someone just taking XNet and deploying it on their local workstation in a lab is very different than an institutional IT team who has deployed it and undergone formal cybersecurity testing. So we are looking to establish an on-ramp and a baseline for all the NIF facilities, as well as other institutional partners of NIF, both on the cybersecurity, maturity, and patient privacy aspect, as well as the computational maturity, so that when a researcher comes in, yes, you're using XNet, or yes, you're running AIS, but what type of data is it rated for? Are there enough GPUs? What is the heterogeneity in mapping that? And lastly, this is not done in a vacuum. This is not done by the National Imaging Facility alone. We have other partners in the INCRIS network that are helping to build this up. Particularly Australian Access Federation with the Trust and Identity program with CI Logon looking to build a national portal. So if you're running a clinical trial, you could say, I want these 7 university sites and just provision across all the AIS nodes. The Australian Research Data Commons for providing the underpinning cloud infrastructure for many of the nodes. As Tim mentioned, we're currently finalizing the scoping work to integrate Globus to be able to move the data between many of the sites. Again, I'm looking at a lot of these new instruments that are 3 terabytes per scan. Needing to move that data very quickly between nodes is becoming important. And lastly, I mentioned we're storing non-imaging data like omics, but we're not looking to become an omics or genomics computational capability. So one of the key things we've done is actually worked with the Australian Biocommons to integrate with Galaxy. So we've developed a tool, XNet Utils, that's now available on Galaxy Australia and will at some point be available on the others. That allows you to push and pull data from any XNet to any Galaxy. So that you can take the data that you have stored in XNet, but we don't have analysis capabilities, analyze it on Galaxy, and put the results back on XNet. And that's it. Thank you.